So multiplication models. The big one we have is the set model or grouping model. So groups of. And then when we combine that with something like base 10 blocks, then we can draw some interesting pictures. So let's take a look at how about 17 times 12. And as far as the groups, I'm going to draw that in an array, an area like we did before. So I want to mark off 17 in one direction. So let's say I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm thinking base 10 blocks. And then I have to go out 1, 2, 3, 4, 5, 6, 7. So that's my 17, and I'm going to have 17 groups of 12, and the 12 is going to come down this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, I went too far, didn't I? Is that 10 there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Almost. Erase. That's where 10 should be, and then there's 12. And so a group of 12 would be something like this, where I have a group of 10 and 2 1s. And I just want to continue those all the way across. So I'm just going to outline this like we did before. Always like to mark off my 10s and then my 1s. We'll draw this with the base 10 blocks too. So this would be a multiplication array. Groups of 12. One extra line. Let's get rid of that one. Come here. Go. So when we look at this, we can see that there's one 100 here, right? And then over here, we have 7 groups of 10 for 70. Over here, we have 2 groups of 10 for 20. And then this group here is 7 by 2. So there should be 14 in that area there. And this also demonstrates what the book calls partial products. And when we stack those, for example, 100 plus 70 plus 20 plus 14, that also relates to the expanded version of multiplication. So altogether, I can see that I have 4 1s in the end. Here we can trade 10 1s for 110. And then that also gives us enough. We have 7, 8, 9, plus that 1 is going to allow us to trade also from here, here, and there. 10 10s for 100. So here I have the 7, 8, 9, 10 right there. 10 10s is 100. So this final product is 204. So we have these partial products that help us get the final product. Now, again, anytime we can do a trade with the physical blocks, there must have been some kind of carry with my way of writing it down, even with the partial products. So for example, 7 times 2 is 14. That's not a single digit number. So that 1 right here is essentially a carry. And then we had 10 10s, and that's a carry over here too. Comparing that to our standard algorithm. So partial products is an algorithm for multiplication. We can do it without the pictures in a couple of different ways. So the standard algorithm 17 times 12, right? We write 2 times 7 is 14. We put the 4 ones there and the 110 up above. 2 times 1 is 2 plus 1 is 3. Right, so there's one of the carries, like one of the trades. And then 1 times 7, that's really 10 times 7, so that's 70. We have a placeholder of a 0, and we get our 7. 1 times 1 is 1. And then 4, 7, 3 is 10. There's our other carry, and there's our 204. So that we can use the area model or group sub with base 10 blocks to demonstrate why we carry, right? To help get kids used to that idea. Again, there's other kinds of algorithms. So the partial products, also referred to as expanded multiplication. And there's 2 ways to look at that. One is more like the way we do it, but there's no carrying involved, at least with the multiplication part. So 2 times 7 or 7 times 2 is 14. We just write both digits down below. And then 2 times 10 is 20. So we really got to keep track of place value. And this is really 10 times 7, which is 70. And 10 times 10 is 100. And so the only time we have the carry is when we do the addition. Sometimes it happens and sometimes it doesn't. Here it will, like we saw before. All right. Russian, that's a wild one. So the Russian algorithm. The Russian algorithm is where we take one number, cut it in half, and the other number we're going to double. So let's say we'll take 17 and cut that in half, and 12 will be the double. So half of 17, well, 2 goes into 17 8 times with 1 left over. We only care about the 8. Half of 8 is 4, half of 4 is 2, half of 2 is 1. And then for every one of those halves, I need a double from 12. So if I double 12, I get 24, and then 48, and then 96, and then we get 192. Separator there. Anytime we have an odd half, the 17 counts, we have to take that double and add it up. So those 2 doubles right there. So if I take 12 and add it to the 192, 2 and 2 is 4, 9 and 1 is 10, carry the 1. So there's my product. And again, it doesn't matter which number you have and which number you double. You could switch it and it's going to work out just fine, but it'll look a little different. All right, lattice. That's my favorite, I think. As wild as the Russian is, lattice is wicked cool. With the lattice, what we do is we write the numbers like 17, and then for the times the other number, we come down with it to form a grid. And then there should be a column for each of the top number digits and a row for each of the side number digits. And then we diagonally slice that. Upper left, lower right, upper right to lower left. There we go. And the lower part is for the ones digit and the upper part is for the tens digit. 7 times 1 is just 7. 1 times 1 is just 1. 7 times 2 is 14. So this place is for both digits. 2 times 1 is 2. And then we follow the diagonals. In the first diagonal, there's just a 4. In the next diagonal, it's 7 plus 1 plus 2, which is 10. Put the 0, carry the 1 to the next diagonal. 1 and 1 is 2. So that one's pretty cute. I like that a lot. And then the harder one for most of us is the Hindu that works backwards, left to right. And so with the Hindu, we start here and we move our way over, down and over. So this is really 10 times 10, which is 100. So they're just going to put a 1 in the hundreds column. And then 10 times 2 is 20, so that's just a 2 in the tens column. And then we're done using the 1 and we move over to the 7. 7 times 10 is 70, so that's going to bump this 20 up to a 9. And then 7 times 2 is 14. That 1 is going to bump that 9 to a 10, which bumps that 1 to a 2. And left to right. Carries end up going down. All right, related to that, I want to just talk a little bit about rounding with multiplication and a couple of other tricks for estimating. And leave that there. So rounding and estimating products. One popular method for estimating is kind of related to rounding, and it's called front-end estimation. And I'll pick a slightly different set of numbers. Let's suppose we needed to multiply something like 235 times 123. So with the front end estimation, we look at the left side of the numbers and we just ignore the other digits. So we could do a front end estimate of this by saying, well, this is a lot like 200 times 100. And 200 times 100 is going to give us 1 times 2, which is 2, with 1, 2, 3, 4 zeros. And we can make a little better estimate by just adding some more digits to that. So for example, we could extend that to be 230 times 120. And then we do the multiplication for 23 times 12 with the extra digits. So just off to the side, 23 times 12, any method you choose. I'm just going to use the standard one. And so each time you can just get a slightly better estimate by adding more digits that you left out with the front end estimation. Now notice I didn't round that 30 to a 40 because of the 5. With the front end estimation, we just grab a digit. We don't worry about what comes before it. So this is not rounding. Different way to do an estimate. Another technique for making estimates is by using what they call compatible numbers. And that's when you have a bunch of things to multiply, like 2 times 3 times 5 times 7. And the compatible part relates to, well, 2 times 5 is rather nice because it makes a 10 in our number system. We love multiplying by 10 because that just tacks a 0 onto it. So we could look at this instead of doing it left to right. We can say, well, how about we just view this as 2 times 5 is 10 times 3 times 7, which is 21. So we can more quickly get 210. And other versions of that, if I had something like 12 times, let's do 3 times 5, recognizing that 12 is even, so I could view that as 6 times 2. And then I can take that 2 and 5 again. 6 times 3 is 18, and I can get 180. So with compatible numbers and multiplication, we look for ways to say, is there a 10 hiding in the multiplication? Let's pull that out first and then do the other stuff, and that'll make it much easier. All right, one more thing about multiplication. When we were playing around with base 5, we decided we're not that familiar with it, and it's good to have a table. So let's just think about multiplication tables in general. A lot of notebooks that you buy inside the cover will have multiplication tables in them. And I remember being very excited about going into 2nd grade because we were going to learn our multiplication tables. And I remember all the 2nd graders talking about it when I was a 1st grader. But I was so disappointed when I got into the classroom because I was expecting a table on one side of the room for the 2s, another one for the 3s, another one for the 4s, but that's not what they meant, right? A multiplication table is where we have one big table, 1, 2, 3, 4. Should space those out a little bit more. And they usually all go out all the way to 12, right, in each direction. Now, just some things to note about a table like this. There's not as much here as there seems. So let's think about that for a minute. Now, multiplying by 11 is pretty nice because you just end up with a bunch of double digits for the first group of multiples of 11. And multiplying by 1 is pretty boring, right? 1, 2, fix my pen. And so on in each direction, right? 2, 3, 4, 5, 6, and so on. So do we really need to show multiplication by 1 in here? And I don't think we really do in either direction. So we can kind of get rid of that row and that row. Multiplying by 11 is pretty easy. That's just double digits for each single digit. So we really don't need 11. Now, kids know how to multiply by 2 and 10, so I don't think it's really necessary to memorize multiplication by 12. I'm not saying don't do it, but there's going to be a considerable number of kids who really struggle with remember their multiplication facts. And if we can show them a way to show, well, there's not really that many facts, as the table shows. So then here, let's just look at the 2's. We're going to have 2 times 2 is 4, 6, 8, 10, 12, and so on. And, you know, we have the same thing going down, 4, 6, 8, 10, 12, and so on. And if we throw our 3's in there, 9, 12, 15, 18, 9, oops, now I got my 9, oops, 12, 15, 18, and so on, and throw in some 4's, 16, 20, 24, 20, 24, a couple of 5's, 25, 30, 30. We've repeated a whole bunch of numbers, top and bottom. So we should point out to kids that there's a diagonal through here. Where the top half of the diagonal is a repetition of the bottom half. So really, we only need, say, the top half or the bottom half. So let's say we don't really need the top half here, and all of this can go. And all we really need is this part down here. So we took this 12 by 12 table for kids that are struggling, and we can whittle it down to a much smaller triangle of numbers that they need to know about. And that's all they need to memorize to get through multiplication when they can't use a calculator. So that's definitely worth pointing out sometimes for the kids that are struggling with some basic facts.